So good afternoon, everyone, and welcome to this statistics seminar. So as usual, it's under the Statistic Across Campuses initiative, but it's a seminar organized at UNSW. So today we're very pleased to have Rohitash Chandra. So Rohit is a senior lecturer in the School of Maths and Stats here at UNSW. Some of his research interests are Bayesian deep learning, neuroevolution, climate extremes, geoscientific models, mineral exploration. And today, Roy is going to talk about BERT-based language models for US elections, COVID-19, and analysis of translations of the Bhagavad Gita. Roy, thanks for accepting the invitation, and the floor is yours.
Thanks, Boris, for your kind comments and a nice introduction. So the overview for today's talk, first I'll talk about a bit about language modeling with deep learning, and then there are four major topics that I will present. It's kind of, we can think of it as four papers. So I'm trying to squeeze a lot in this one presentation. And the first one would be about Twitter analysis leading to the US 2020 presidential elections, BERT and Biden, and how we think that Twitter analysis, sentiment analysis can help in election modeling in the future. Then sentiment analysis during the rise of COVID-19 in India, cases last year and before or while reaching the peak, what type of sentiments people were expressing. And then the last two are more preliminary results that I will discuss about translations of study of Hindu texts such as the Bhagavad Gita and the Upanishads. So a bit of background in the area. What is sentiment analysis? Basically, it's part of natural language processing, text analysis, computational linguistics, and biometrics. And it uses language models to identify, extract, quantify, and study affective states and the emotions. Sentiment analysis has been used for marketing and advertising, analyzing customer reviews and surveys, social media analysis, and applied to various domains, including medicine and public health. And we are basically exposed to sentiment analysis algorithms every day whenever we are using Twitter, LinkedIn, and Facebook, social media apps, whenever we are in Google. Basically, there are bots collecting information on how we are reacting when we are writing comments, and that all is used for marketing and advertising. So they are bots, and those bots are collecting information, and they are further fed into AI or language modeling algorithms, and that help marketing companies and social media to raise their profile. So topic modeling is basically used for discovering abstract topics that occur in a collection of documents or text corpus, and it is used for text mining, and it's used for discovery of hidden semantic structures in a text body. A document typically contains multiple topics in different proportions, hence it is a challenge for natural language processing algorithms and models given ambiguity in expressions. We know about this through Twitter and social media. The big challenge of language models is how do they deal with so fast changing expressions, emojis, emotion expressions, and these days those expressions are going into memes and so on as well. So these are big challenges, and there's a lot of ambiguity, and due to word limiting, for example, Twitter, people express a lot of things in so-called shortcuts, and this becomes difficult for language models. And topic and modeling can be useful in a lot of applications of social media analysis, such as understanding public behavior during events such as elections and public behavior during pandemics, how people have been expressing. We can understand the psychology of the population and individual groups as well with topic modeling. And of course, topic modeling again is used for marketing and advertising as well. So one of the key models in the whole neural networks or AI field is recurrent neural networks. So where do we place recurrent neural networks? So if we see artificial intelligence as the root, then under that root comes a number of branches, and we can see machine learning as one branch, optimization is another branch, and there are other branches. So under machine learning comes neural networks, and under neural networks there are major neural network architectures such as simple, canonical, or feed-forward neural networks. And then there's a major group called recurrent neural networks. And basically, recurrent neural networks are quite prominent in processing temporal sequences in dynamical systems, and they have been the forefront of language models because of the ability to process time variant information. And the dynamics of a change of hidden state activation in a simple recurrent neural network is given by the following equation. Perhaps we go back first, see the figure. And here what we see is very simple. One of the key guys who developed a simple recurrent neural network was Elman, and the other guy was Jordan. So an Elman recurrent neural network is sometimes referred as the simple recurrent neural network. And what we see here is a figure where here we see just one input neuron and one hidden layer and one output layer. And there's basically context layer that provides state information to the hidden layer. So if we compare this with a feed-forward neural network or a multi-layer perceptron, we will not have this feed-back connections. And the major part of recurrent neural network are these feedback connections that help them to model time variant information better than generally than feed-forward neural networks. So what we see here is more of a plan view. The same neural network, recurrent neural network, unfolded in time is given here. So we can see this as more of an elevation view. So what we have this D of 1, 2, or 3. You could think of it as T of 1, 2, and 3. So if you have a univariate time series, basically in a feed-forward neural network, if you do windowing, if your window size is 3, then you will have 3 input neurons in a feed-forward neural network. Whereas in recurrent neural network, you'll just have 1 input neuron, and basically it recurses 3 time steps, basically. So that is the key part of a recurrent neural network. And recurrent neural networks, I mean, they are visualized differently, and there's a major problem is the time steps. If these time steps basically are too large, if they are more than 12 or 15 in some simple applications, then it becomes very difficult to train these neural network architectures. So that is not the vanishing gradient problem, and this was known in the early 90s. And because the problem is major algorithm that is used to train feed-forward and recurrent neural network is backpropagation, and the algorithm that is specifically for recurrent neural network is backpropagation through time. And backpropagation through time basically fails when your time lags given here are more than 10 or 15 for most applications. So hence that the reason it fails is because propagating error backwards over time for longer time steps, more than 10 or 15, basically the gradient becomes too close to 0 and you cannot make much of the weight updates. Hence, the LSTM, or the long short-term memory recurrent neural networks, were proposed. So the LSTM is a recurrent neural network. So it could be seen as something that comes under recurrent neural network. It's a special type of recurrent neural network designed to address the vanishing gradient problem. And the way it is done is the way it has done the authors have proposed basically memory cells and gates in the hidden layers, and they are a way they are used to basically capture um, uh, the structure in memory better, so they can process time variant information better. So these LSTM networks, they have shown to work for more than 1,000 times steps. So when compared to simple recurrent neural network of they can only work with 10 or 15 time steps. So this makes them very popular for a lot of applications. So you would not have, if you were doing if you had a language model where you had some sort of analysis of certain paragraphs. So if your paragraph was very large, and you were basically labeling a paragraph by topic, if you have paragraphs labeled by topic, if your paragraph is very large, if the paragraph has more than 50 words or more than 100 words, then basically simple recurrent neural network would not be able to take care of it. But a simple recurrent neural network mostly would be able to work with tweets, because they have a limit. So LSTM for language modeling, basically you could, in the area of language modeling, because we know that neural networks or statistical models, generally they work with data that is real numbers or discrete data sets, right? But in languages, we know that they are expressed as characters. So we need to basically convert those characters into some sort of representation. And this what we see here is a very simple language model, and it is a LSTM for language modeling. And here basically the representation is not explicitly shown. Oh, we can see the representation is explicitly shown with one hot encoded vector, and basically it's set of input characters are given, and basically the target characters are given, and the goal of the neural network is to see the mapping from the input to the output, and you'll have a backpropagation through time-based algorithm which will be training it. So that's basically the background of recurrent neural network and LSTM models, and these LSTM models can be used to basically predict future words, such as when we are typing in several apps these days in LinkedIn. I don't recall if we are doing it in LinkedIn, but in a number of apps, we keep on typing, and they keep on helping us to correct our spelling as we type, or propose or predict what are the future words that can be used while we are typing. And those things can be done with the LSTM model. And they are usually trained on a very large corpus of text, and based on user behavior, it can take current information and predict what are the future words in a sentence that we are trying to write. So what are transformers? So transformer is an extended or special type of LSTM model, and it basically takes the concept mechanism of attention, as in cognitive attention. When we give attention to specific words in a paragraph, we do not memorize entire paragraph when we are trying to remember it. We will usually have attention to specific words in a paragraph, and that basically then we relate it to some meaning, right? And that basically idea is used by LST transformers, and transformer is a very complex architecture of somewhat stacked LSTM in an encoder decoder framework. And when we compare to traditional LSTMs, transformers do not require data to be processed in a sequential order, since the attention operation provides context for any position in the input sequence. So that's a major advantage of transformer networks over LSTMs. And we can see here that we have a overview of our transformer network with showing attention mechanisms and different operations. And essentially, these transformer networks are very large. You have very simple versions of it. Usually, you will end up with a couple of million parameters for even for small data sets. So then moving on, we have BERT, and the T in BERT is basically the transformer. And it is developed by Google. It is basically a transformer which is pre-trained on a very large corpus language data set for language tasks, and it's basically the part of it is open for free use, and the some parts are not open for free use. So in our project, we are using in BERT, we are using the BERT-based, which is available as for free use. The idea is basically that BERT is using, it's pre-trained on a very large corpus with 800 million words, English Wikipedia with 200 and 2,500 million words respectively for the BERT-based and BERT-large. And different embeddings are used. If you do not use BERT, then there are other ways to train LSTMs. You need to use language embeddings, meaning that you convert your sentences into a vector of real numbers. And some of the language embedding method, word to vec and glove, and they basically provide context-free models to generate a single word embedding for each word. And compared to them, BERT takes into account the context of each occurrence of a given word, which makes BERT as one of the best language models. And because it is trained by such a large corpus, it has shown to be better than LSTM and transformers on their own. And so the great part of BERT is that the limitation is that it has millions of parameters. But the great part is that you do not have to train those millions of parameters yourself. You have BERT available online. The trained model is available online. All you need to do is download that trained model, and then you basically kind of you can tailor make it to suit your needs. So you can have your data set. Perhaps that data set may not be available or used in the original BERT data for training. So you basically are um, uh, fine-tuning your BERT model with a new data set. You can do that. So moving on, as you can see here in the literature, in many websites these days, the way they describe BERT with Sesame Street, you know, the character BERT there. So basically, a lot of websites and these days some papers, they also put a cartoon character BERT to show BERT. So that is all about a very fast, rough overview about language models with LSTMs, transformers, BERT, and major problems such as sentiment analysis and topic modeling. And now, basically, we discuss some of the key applications of these that I have been active in. So these applications actually, when I entered the School of Mathematics and Statistics, I had no knowledge about language modeling, and I did not do any work on language modeling before. So this is these applications are more planned right at the School of Mathematics and Statistics in my office and home. And I would say this is a product of UNSW. And otherwise, my other research areas such as geoscientific models, neuroevolution, Bayesian neural networks, those are some of the things that I came to UNSW with. But this is something that is unique to UNSW. So the first project is looking at using those language models in understanding the US general elections. So we know about this quite well because the media was very active in promoting the elections, and there were very much a lot of fierce debates between Trump and Biden, and there were almost daily tweets by Trump back in the days, and those daily tweets, some of them were quite controversial, and they were part of major discussions. So there's basically the deep learning in these language models, recurrent neural networks, LSTM, and BERT. These things were not very prominent before 2010. They were there, but they were not really the forefront of language modeling. In the last 10 years, all these technologies have overtaken natural language processing. And they are becoming more and more prominent in sentiment analysis and topic modeling. And Twitter is very prominent application of these models, because the reason Twitter is used widely is because Twitter has this app that it allows users, researchers, to download data. So all the tweets that are public, we can download it, but it's not a straightforward process. There are a lot of restrictions in how we download it, and we can only download it um, on amount for a day, basically. So sometimes it will take us weeks to download the data. But for this project, we did not download the data. We used existing data that other people downloaded. And social media, of course, plays a major crucial role in shaping the worldview during election campaigns. And there have been a lot of discussions about controlling social media during elections, probably banning even them during elections, because it can be used as a tool of political propaganda as well. And in the US, we have seen that it led to violent riots, the Capitol riots during the 2020 presidential campaigns. So there has been previous research that already there that shows that understanding behavior in terms of sentiments during elections can give us some indication of the election outcome. And I have already talked about the background, that basically it was a very intense competition between Biden and Trump, and there were political unrests. And we also note that President Donald Trump, back then he was president, and he was banned by Twitter for some of the comments he made. So basically, we present a framework for sentiment analysis where the state-of-art language model to understand public behavior during elections. And in the paper, we show results for both BERT and LSTM-based language models for sentiment analysis. The thing, what are we using? So basically, BERT already comes pre-trained, and it already has sentiment analysis, the power to perform sentiment analysis. But we basically take the BERT model, and then we again train it or fine tune it with the IMDb database, which is quite a large database, and it has polarity scores between 1 and -1, indicating positive and negative sentiments. And basically, we investigate in this paper that if sentiment analysis from social media can help in modeling and understanding voter behavior during elections. But this is basically the overview. We have the BERT transformer, and we have the LSTM language model, and we have the tweets. There's pre-processing and cleaning, and a lot of effort was made for pre-processing and cleaning. And then we get the sentiment polarity scores and analysis of time series data with sentiments, and then we do state-wise comparison between final results. That means the final results of the elections and the overall sentiments. So the tweets, basically, the source of tweets, you can see that there's a lot of tweets all around the world. In particular, major sources are in Europe, US, and also in India. Over the last few years, actually, India Twitter users have been exponentially growing, because the number of internet users in India are now around 750 million, and they are next to China, around 900 million. But China is having we all know that they are not open to social media from America, with Facebook and Twitter banned. So that's why we don't see much from there, but we still see some dots there. Maybe it is because they may be using VPN and so. Right. So the problem with the data is that we found that there's a lot of missing values, and what we did was we discarded the data from the rest of the world. We were only interested in what American voters think about Biden and Trump. We do not care about what the rest of the world does, because we wanted to see if it can help us in somehow estimating or predicting something about how the states are going to perform. So with the data, basically comes all this information, such as state codes, which continent, city. So this kind of helped us to get those users that are not in US, basically. And here, basically, what we see is the data sets, the number of tweets that have the terms Trump and Biden, and how they basically increase over time till 11th till November, basically. And basically the data set. So we note that the model is there, and it is using the IMDb data set. The model on its own, it does not know anything about the elections or anything about the Twitter data sets. It's basically BERT plus IMDb data set trained model, which will give polarity scores if you give it even some made up data or made up tweet. But we are then presenting it with tweets from US elections relating to Trump and Biden. And basically the tweets, we do get the bigrams and trigrams to see what are some of the key terms expressed. And we see Joe Biden, of course, in the Biden related tweets is the most, but we have other things expressed as well, such as Vice President, President United, and then we have trigrams on the bottom. And then for Trump, we have anti-Trump as well, election day, and others, and Donald Trump. And surprisingly, in both of them, yes, it's kind of not a surprise, because they are opposing to each other, so people have been tweeting about them. So we see Joe Biden as next to Trump. So after basically modeling, we see scores, the predictions state-wise, and taking the state-wise predictions, the polarity, the positive and the negative towards each of those candidates, we basically then labeled as came to a decision where in which state which candidate will win, and which are the states where it's contentious. Contentious is basically it's not sure which candidate will win, because the polarity scores are very close. So what basically we found is we also compared the BERT model with the LSTM model, and the LSTM model was not a pre-trained model. it was just trained from the IMDb data set. And here in the LSTM model, what we see is that a lot of states are shown as states, whereas in the BERT model, in the BERT model, we find that the BERT model is giving very much close results to when you compare to the actual results. Whereas if you compare the LSTM model, basically we see that it's basically over predicting contentious states. So this is basically our final result, and there are other results which are basically part of the paper. Is everything okay? Can I continue?
Yeah, all good, right?
Right. So the thing is, you can see that we analyzed only 1.2 million tweets associated with the US presidential elections. The problem was like more than 90% of the tweets basically were not giving their user location. And that basically is a huge problem for this kind of analysis, because people do not want to express where they are. And we found that given BERT model basically indicated that Biden had better chance of winning, and given more data and geographical information, we think that sentiment analysis can be helpful in elections. Moving on, we apply a similar model, BERT model, for sentiment analysis, and we see the visualization of the of the coronavirus, and we know that the coronavirus, there was a lot of hurdles, there were lockdowns, and there was a huge change in a very short time, and it was known or labeled as a catastrophic event. And a lot of psychological issues, depression and social changes, lack of employment, and so on. And hence, basically, I thought that it would be interesting to see what type of sentiments, what are people writing on social media. And this project began towards November of last year. So we looked for some data sets and hence we present using the existing data sets. We present LSTM and BERT language models and see how. My concern was more about, as the number of cases rose so the country that was selected was India. The reason that I selected India was that there was not much done for the case of India in COVID-19 modeling. Less work was done compared to other parts of the world. And the other thing is that India had a single peak of cases, and that was the peak was, and basically that kind of made me ask the research questions, motivated me to ask the research questions that given a single peak, how do people express themselves? Basically, our framework uses multi-level sentiment classification. So multi-level, hence in here is where you have one tweet can have two different sentiments or three different sentiments. That means a tweet can be sad, pessimistic, and anxious, right? So that is defined as multi-level classification. So the data set, although we use both LSTM and BERT, here the data set for training was different. The data set for training was human level sentiments from 10,000 tweets worldwide by 50 experts. And that is a published data set. And we used there were 10 sentiments that were in the training data set. And we basically applied the BERT model. We trained it with the sentiments which were handleable, and also the LSTM model. And here what we see here is looking at then then after training, we then get the data from India, and the Twitter data set was also published, but not labeled. So we get the data set from India, and we do some data analysis, and we see that over the months, this is the part which motivated me to do this work. You can see that there's a single peak. Basically, this is the peak around September, and then the cases lower after that. So that's the blue is the number of cases, and the red is the number of tweets that were expressed about COVID-19. So you can see that a time comes when people basically stopped expressing that much, and that is when the peak was reached somewhat then. And what were the top bigrams? Coronavirus, and we have folded hand. Folded hand also refers to namaste or please, and these were basically expressed. Folded hand was more of the emoji that was expressed, but we converted the emoji to text. And the top trigrams, also the first one is the backhand index pointing is emoji, and the feisty, joy, and all these expressions. So some of them are combinations of emojis, and these are some of the challenges in language modeling. So we are looking at the data set, the hand-labeled data set for training. What are the two major sentiments that were expressed? So, for example, in the training data set, we have optimistic, and the outlier here is an official report, which is not a human sentiment, but it was just present in the training data. So we used it because we thought that it will be useful as one of the classes. We can see here that in the training data set, for example, people are optimistic when they see official reports, and then basically, and they are, a lot of the time, they are optimistic and joking, for example, right? They are optimistic and joking, and of course, they will be very, the times when they are optimistic and empathetic is they are optimistic is so pessimistic. So we are looking at a combination of two sentiments. And basically, we took that data set, we trained the model, and then we basically took the data from India, and then we look at optimistic and joking, optimistic and thankful. And this is for the entire duration of about um, 6 months from March or April to September, something like that, the data. And these were some of the predictions. We in the predictions for the entire data set, we see that the number of sentiments, uh, multiple levels, so multiple sentiments expressed at once, where for 2 sentiments expressed were for less than 40,000 tweets, and 3 sentiments were very rare, and sometimes there were no sentiments expressed. So, and whereas 1 sentiment, and this is what the BERT and the LSTM language models showed us. In the paper, basically, I show a comparison of LSTM and BERT predictions as well, and they are not that different. They're close, and this is the part that really drove me, and I find this is one of the key results. Basically, that over time, what are the key sentiments that were expressed? So what we see here is that joking and optimistic are the 2 sentiments that were most expressed as the COVID cases rose. Note that the peak was reached around September, but in September, the number of sentiments expressed were quite low generally. But these months, June to July, August, people were expressing a lot, and they were joking and optimistic mostly. So, and other findings is that optimistic, annoyed, and joking tweets mostly dominated the monthly tweets, with much lower number of negative sentiments expressed. So generally, we found that people were very much optimistic, but they were also a bit annoyed, uh, according to some of the sentiments. and minority of them were thankful. In terms of the annoyed sentiments and tweets, mostly were either surprised or joking. These predictions generally indicate that although the majority have been optimistic, a significant group of the population has been annoyed towards the way the pandemic was handled by the authorities, and this is not surprising. So moving on to the third project, I know I'm running out of time. Basically, the idea was to bring these models and let's study something different. So this is now going into humanities, philosophy of religion, and in a completely different area, and where there's some work done on analysis of Hindu texts. And basically, what we see here is an event from around 5,200 years ago, which is the Mahabharata war in India, where we have Arjuna, Lord Arjuna, who is known as the avatar of Vishnu, and we have Arjuna, who is the warrior, who is the key warrior in the war. And basically, the text that we are interested in is the Bhagavad Gita, which basically there's a bigger text known as the Mahabharata, and Bhagavad Gita is like a chapter from the Mahabharata. If you print out the Bhagavad Gita, it's not that long, it's around 50 pages, right? So, but what is the Bhagavad Gita and why is this war important? Because this is a war where two family member sides of a family, they go onto war and they are fighting for their rights to lead, rights to the throne. And basically Arjuna here, before the war begins, he is like not sure if he should go to war or not, because on the opposite side he has seen that his family members are there, his cousins are there, his gurus are there, and he has to fight them and he has to kill them in order to win the war. So he lays down his bow and then he starts talking to Arjuna, to Krishna. So Arjuna starts asking Krishna a set of questions, and the questions he asks, the answers he gives, that's basically the Bhagavad Gita. And it is like, should he go to the war, have this war or not? So from the Bhagavad Gita, we have some key concepts which are mentioned quite a lot in our everyday language. For example, gurus, dharma, the concept of karma, and selfless action, and yoga. Some of these terms are from the text, the Bhagavad Gita. And in the last 2 centuries, the Bhagavad Gita, it is believed to be a conversation between Krishna and Arjuna, but this conversation was sung for millenniums, and it was only written around, some scholars say, between 2,500 to 3,500 years ago, right? So, and it was written in Sanskrit, and basically for the last couple of thousand years, this text has been translated mostly to Hindi and Indian languages, but in the last 200 or 300 years, it has been translated to German, European languages, and a lot of other languages. So the thing is, the problem is because it's been translated so much and has gained a lot of attention by Western scholars and academics worldwide, there's a number of different translations, and which translations are valid, what can be what studies are there about the difference in the translations. There are a number of studies, and what I'm bringing to this is that we use this BERT and LSTM language models to understand the differences in the translations, both in terms of semantics and sentiments. So the 3 translations that I am looking at are basically one by Mahatma Gandhi, and Eknath Ishwaran and Shri Purohit Swami. And as you can see, the dates of the translation, there's a huge gap. And basically, because of the gap, the type of expressions in the translations have changed as well. And the thing is that what we need to say, what I need to emphasize here as well, is Bhagavad Gita. The term itself means Bhagavad or Bhagwan, it means the enlightened one, or it can also mean God. Gita means song, and it literally translates as song of the divine or song of God. And God here is Krishna, and the way it's written in Sanskrit and also the Hindi translations that I know of are all poems that you can sing, and they are rhyming, and people have memorized them and they can sing. And the major problem is that with poetry, when you translate it, a lot of people have different viewpoints. And the another problem here is that this is not just poetry. Even the modern poems, like if you have English poems written now, I mean, I'm a poet myself, and I write in English, and then I have seen Google Translate and comparing, and then it translates to Hindi. Then I read it. Sometimes, a lot of times it doesn't really get what I'm trying to say, but it's interesting. And basically, this is a text that is also the forefront of Hinduism, and it is equivalent to the Bible for Christians. For Hindus, the Bhagavad Gita is the key text that has the same respect as the Bible. So, looking at some verses from the Bhagavad Gita, two translations, one Shri Purohit Swami and one we have by Mahatma Gandhi, we see that on top it's talking, saying, it is desire, it is aversion, born of passion. Desire consumes and corrupts everything. It is man's greatest enemy. Whereas 37 on the bottom, it is lust, it is wrath, born of the guna, rajas. So guna features, rajas is type of mental expression. Basically, this is Sanskrit. So in this translation, some of the key terms which the authors thought are not easy to translate into English, they kept this, Mahatma Gandhi kept the Sanskrit, whereas the Shri Purohit Swami, he doesn't do that. He forcefully translates it. So as fire is obscured by smoke and mirror by death, the embryo is the Armenian. So is the knowledge obscured by this. Knowledge is obscured, O Kanteya, by this eternal enemy, and so on. Here basically saying something similar, but here what I want to highlight is saying, O Arjuna. So basically Arjuna also has a number of different names, and some translators use Arjuna, some use Kanteya. So there are all these different text pre-processing we had to do to bring them into one page, so that they speak the same language. And basically the text processing, we had to change the archaic words, we had to change the name so that it's in the same name, same domain. And basically we use BERT, and we are using BERT for the sentiment analysis, and also, and we are using other methods for semantic analysis, and so on. We look at verse similarity by word embedding models, word to vec, and so on. And basically we have the original and the transformed sentence. This is just text processing where we are changing things, pre-processing. And after that, what we did is I took advantage. There in the literature, there's not much data where we have people hand labeling sentiments, So, and this was great. The COVID send wave data set where 10,000 tweets were hand labeled by 50 experts. I saw that as an opportunity. And basically, I thought that let's basically use this not for just COVID research, but for understanding the language text, because I am assuming that the key, yes, we can assume that the key sentiments, either it's expressed through Twitter or through other text. When people see sentiments, uh, I mean, the sentiments would be same, right? So, or similar. So the idea is basically looking at chapter by, so there are 18 chapters in the Bhagavad Gita, 700 verses. So it's not a long text. You can print it in 50 pages, as I said earlier. And we can see that in chapter by chapter, we see the different authors basically here are expressing the sentiments. Different chapters have different counts of the sentiments. Basically, it's not going to be exactly the same. And it's quite obvious because we have seen some examples of the two different authors expressing things, but we have again cleaned that. And the other thing is, and processed it, but still we see that there are these differences in the sentiments. The other thing is the 10 optimistic and pessimistic bigrams we see. So the optimistic ones are the supreme goal, creature, selfless service, pleasure, pain, attain supreme selfish attachments, spiritual wisdom. On the other side, time, death, home, world, nature, divine. One major part is the sons of Dhritarashtra, which it kind of somehow saw it as pessimistic, which is important because Dhritarashtra is seen as the sons are on the opposing side of the war, and they are the people causing trouble, and that there is some mention of them, and somehow the model has picked that quite well. Then moving on, the final project, I'll just summarize that we are applying. Actually, in this project, we are yet to do the semantic analysis. So we'll do a semantic analysis and have similar results like this, and we'll show statistics, and we'll also have chapter by chapter work, the verse by verse semantic and sentiment analysis, and we will present that all in the paper. And then moving on, basically, there's the Upanishads, which is known as the oldest, one of the oldest philosophical texts in the world, and basically is composed, took more than 1,000 years of composition where basically seekers were going to the gurus, and gurus were basically some kind of very general questions the seekers were asking. They say, Guru, namaste, what is the meaning of life? And the Guru will say something. And they basically noted it down. So this is basically the Upanishads. And what we are trying to do is see what is the mapping of the Upanishads in comparison to the Bhagavad Gita. So the Upanishads, similar to the Bhagavad Gita, they are somewhat divine text, somewhat holy text for the Hindus. But the Bhagavad Gita has is prominent in the West, and so is the Upanishads. So, for example, we have some key key scientists here, and Carl Gustav Jung, of course, psychologist, and they basically studied the Upanishads, and Niels Bohr is saying, I go to the Upanishads to ask questions. The rest, I'm running out of time. But they are have been very prominent in the West. So some of the things famous, one of my favorite famous verse on the Upanishad is, you are what your deep driving desire is, as your desire is, so is your will, as your will is, so is your deed, as your deed is, so is your destiny. And the rest are, the other one is, knowledge is twofold, higher and lower. The study of the Vedas, linguistics, rituals, astronomy, and the so-called arts can be seen as lower knowledge. The higher is that which leads to self-realization. So we basically have this whole framework where we want to compare the topics of the Upanishads with the Bhagavad Gita, because it is known by Hindu philosophers or even Western philosophers and academics studying Hinduism. They say that Bhagavad Gita summarizes the Upanishads and the rest of the Hindu text, and it is the center of the text. So we want to see what type of topics are mapping between the Bhagavad Gita and Upanishads, and we have UMAP and PCA embeddings we did, and we're looking at the topics, and yet we have to show the results from BERT and others. But some of the topics have been, and we have some kind of similarity score between them and some ID. And basically, the Upanishads that we are looking at are only 12 major Upanishads, which are so. But there are actually 108 Upanishads. So we are going to further apply these things to the 108 Upanishads and see the mapping and sentiment analysis as well. So what are some of the limitations and challenges in general? As I said, availability of data and geoinformation for the Twitter kind of analysis, and interpretation of conversational expressions and language, interpretation of poetry, songs translated from ancient languages, limitation of language modeling for Indian languages. So we don't have much work with BERT and Sanskrit, BERT, and Hindi. It's upcoming. So these are some limitations that can be addressed. And collaboration with academics in arts or humanities, lack of funding for humanities research in Australia, and recognition of interdisciplinary humanities research by scientific journals. So it will be a question for me, where do we submit this research? And then personally for me, after publishing some of these things and also talking about it, being misrepresented as a priest or theological when studying philosophy of religion. My interest is philosophy of religion. Future work, we are going to apply, we are in the process of applying these BERT models to anti-vaxxer sentiments in Twitter in collaboration with Cyro, and language models for understanding and analysis of patient experience in Australian hospitals. We are acquiring data, topic modeling in evolution of ancient poetry and songs, not the Bhagavad Gita, but others. It could be English poems as well, and political biasness in media reporting. And finally, which I did not write, is also awareness of climate change and related topics in Twitter. What sentiments are people expressing? And I would like to say thanks to Ashwin, Mukul, Shweta, and Venkatesh. These are the guys, my group for philosophy of religion and language modeling. And Roger is a master student acquiring hospital data. Kathy is a master student doing the anti-vaxxer project with Prof. Sheshadri Vasan from Silo. And special thanks to Indian Institute of Technology. The top ones are the papers for sentiment analysis and topic modeling, US modeling, election modeling, already published. The bottom two will come by January. I'll place them in archive by January, at most by February. Yes, and thanks. Sorry for being late. All these projects and software, all the papers basically have a GitHub repo, and everything is there. And all the processing of the text, the data will be also published along with the models and the results. Thank you so much. Your questions?
Thanks for it. That was great. Many different stories and different topics. So we can take a bit of time to for some questions. So if anyone has some, right, there's one maybe to start from Stefan in the chat.
Yeah. Are bigrams the word or token in pairs in a sentence or tweet the transformer assigns most attention to in order to make a sentiment prediction? No, actually, we do not give them the models bigrams and trigrams. The bigrams and trigrams were just used for data analysis and just for visualization purpose. It's not really part of the model. The model is supposed to get better information than bigrams and trigrams with help of BERT and LSTM architecture to make the sentiment prediction. Okay, thanks, Pierre, and thanks, Yan and Fang. Any other questions?
Maybe while anyone, or Stefan, you're muted. You want to clarify or say something?
Oh yeah, I did. Sorry, I don't think I can share my video. Some sort of permissions issue. But just following up from that question, it is a transformer in the end, right? And so I'm just wondering if it is possible to extract the attention mechanism information. So surely certain words in the tweets or sentences would be assigned more attention to. And I'm wondering if once we make a prediction, we can extract that sort of information as well in order to increase the interpretability of the model itself.
That's a wonderful comment. I would really take that into consideration and improve our next coming papers. If I presented this earlier, probably I would have published that result. Thank you, Stefan.
Thanks.
I think Jan has also a question.
Thanks,
Hi, Ian.
Rohitash. Yeah, allow.
Sorry.
Jan, you're muted now.
Sorry, I thought I'd unmuted, but great talk. So I guess I have a few questions, but one, I guess, is what do you think about the issue of the representativeness of the discussions on Twitter versus the population as a whole? Is that something that you have ideas about how to address, or do you think that's very it's sort of completely separate issue to what you're doing in terms of public sentiment? So, like, as in, does Twitter subsample a certain group of people, like maybe particularly politically active or high information content level people? Do you have thoughts about that?
Yes, thanks, Ian. The thing is, our model is not looking at what tweets are or posts are more prominent than others, but that happens, right? We see in LinkedIn or Twitter, some of them go viral, but the way we are looking at the data, we are not looking at that information at all. So basically, we are fair in that sense. But yes, there are major limitations, as we know. The censoring problem is there, and really to have use this for something critical like election modeling, it's not there yet. Probably the model. It's just that I have presented a framework, and the availability of data and the quality of data is a big question mark. And this also applies in future projects when we dealing with Twitter. The thing is that less than 90, very small portion of users actually give the geographic location. So let's say if we're doing another project where we want to do something similar about elections in Australia, unless people make their location available, there's unfortunately people are more comfortable in sharing some very personal things, but they find city information very personal to share. But they would share, they would share what they are eating. They would share, write something which which can get them fired. But they won't want to share city information. And this has been a problem with me, because with Sairo and Professor Vasan, we were planning on doing another project where we want to see the spread of the virus, and then how we can use Twitter for that. And in the past, it has been used, but Twitter users are becoming more and more, sensitive about sharing that information. And I hope that in the future, somehow Twitter hears our plea, and people hear our plea that in sharing your city information is very useful for geographic data analysis. Otherwise, in the other domains, such as accessing non-social media information, such as for building these language models, such as the religious texts, or it could be not just religious texts. We could be using them on other texts. We could be analyzing how our textbooks are expressing sentiments, what topics are in our textbooks. For example, some critical things. Now we have a huge discussion about representation, or making mathematics, represented by other ethnic groups. Aboriginals represented in our text, or in a high school or university. So those things we can do a lot of things.
And are they represented positively? Absolutely.
Yeah, that kind of stuff. Probably we can do all those projects, and welcome everybody from the school to be part of these things. Let me know, please.
Interesting. Thank you.
Thanks. Oh, thanks for sharing the video.
Yeah, thanks for the link.
Yes,
Yeah.
and there are questions about BERT, transparency of BERT as well, and there are other pre-trained models coming which are competing with BERT and so on. And it's not that BERT is the key, is the end of the modeling era. I mean, it's known as a state-of-the-art models, but these models, they do not remain state-of-art for long.
Yeah, Rohit, I have a question that is more one it's not really about the model, but in some of the diagrams that you had, at some point you had one that was, I think, optimistic, pessimistic, and in the optimistic you had a diagram that was pleasure and pain. So is that a is that an optimistic one? Like,
Yeah,
I guess you can go in both, right? Or like, what's the judgment to put it there?
I think that is a good catch, Boris, and you that's a very critical question, and we do have to address that in our paper. And I think we need to kind of go back to that exact sentiment what score was given. Probably there were maybe two, like some of the sentiments. This is multi-level classification. Then there are couple of sentiments expressed at once, and somehow because we may have blindly grouped them as bigrams and trigrams without looking at the exact other sentiment, so what were the other sentiments. So I think we need to probably redo that figure and show that somehow make sense of it. We need to see why it is viewing that. So there have been also some cases where people have been optimistic and pessimistic kind of at the same time. So those are some of the challenges that we need to really highlight, and they are some of the problems with BERT-based modeling. But I just want to say that we may be pointing a bit too many fingers at our BERT model here. It's still, this is kind of novel in this sense that it is bringing this to humanities area, although sentiment analysis and social media is not new. But the thing is, we may be bit harsh towards these models, because if you look at multi-level sentiments, I mean, if we give humans generally to recognize sentiments, and to recognize more than two sentiments or two sentiments at once is also quite a hard task for humans actually. So that is being done by these models, and so that is something to think about. Thanks, Stephen.
Yeah, that was a good point, Rohit. All right, I think we
Sorry.
can thank you again for this great talk and the good discussion that comes with it. So I'm clapping. I hope everyone is clapping as well. And wish you all a good weekend.
Thank you everybody for participating. See you all later. Namaste.